Okay, so let's start. Okay, good afternoon, everybody. So last time, guys, before the break, I started chapter 3. Okay, so here I explained this program. How can you program LEDs? As you see here in this board, we have LEDs here, as you see them here. Okay. Sorry. Okay, so as you see here, guys, we have 8 LEDs. Last time I explained how can we program them using assembly language. One more thing I told you guys, every program starting from chapter 3, every program I'm gonna teach, in the slides, I'm gonna put C version and also assembly version as well. Okay. And I told you, you can find all these programs on the course website. So here I put the name of the program here, as you see. So for every program, I'm gonna do that. So for example, this one in C language, this is the name of the program. So if you go to the course website, here, okay, you can find, I have posted several things here. So you can find here, yeah, chapter 3 C and assembly programs are here. So all what you have to do, just download this file in order to get all the programs you have in chapter 3. Okay. One more thing I told you last time, guys. Here I used the function, this function delay y ms. I explained how this function works. I used this function in order to make a delay. Okay, I explained how it works. And I'm gonna continue doing the same thing here in this chapter and also the coming chapters. So we are gonna have too many functions. So to make programming easier for you, I told you all what you have to do. You don't need to copy and paste every function you have to use, okay? Because this is going to be too difficult, especially if you use too many functions as we are expecting, okay? So all what you have to do, what I did, guys, as I told you last time, I put all the function in one file. I call it subroutine.include, and you can find when you download the programs here. When you download these programs, you are going to find this file there. Open this file, okay? When you open this file, you will find it has many functions. Okay, so I'm going to explain all these functions and we're going to use them. All what I want you to do, guys, just to make programming easier. Here, also I give you a tutorial on how can you use this include function in your program. Very good idea. So all what you have to do, guys, you can just use the function. After you include this file, okay, you just use all functions I'm going to teach in chapter 3, 4, and 5. Is that okay? So you don't need to copy and paste in your program any functions, okay? So let me open it here. I give you here a tutorial. So I show here in this tutorial, guys, I don't want to spend more time, but I just want to make a quick revision on what I said last time. It's very detailed tutorial. Number one, you have to make sure you have to include the file here under includes in your project, okay? So similar to what started from chapter 3, similar to what we did before, you have to create a new project similar to what you did before, and you have to select assembly, you have to select our microcontroller, similar, but on top of that, you have also to include this file. Otherwise, if you don't include the file and use the functions, as a code warrior is going to give you error. It's going to tell you, what is this function? You are using a function, but you didn't program it. You understand what I'm saying? So here I'm explaining how can you include the file here this way. Very easy thing to do. So you have to locate, yeah, this is the file I'm talking about. Okay, you have to locate the file. Once there are two things you have to do. Number one, you have to copy the file and put it in your project. You have to do that. Number two, you have to write instruction in your program to ask a code word, you have to include the file. So here, what I'm explaining here, guys, how can you copy the file and put it in your program? So very important. So you have to make sure, guys, you have to see the file here. If you don't see the file here, that means you did not copy the file in your project. Very easy. Okay, that's number one. Are you done? No, you are not done. You copy the file to your project. However, you didn't write an instruction to include this file in your project. Most of the students are going to make this mistake. We do include here. We already used to include before, but be careful. Why you have to be careful? This include, if you open this file, you can find it has equate. It doesn't have instructions, only equate. That's why I put it here. However, this file is different. This file has code. So you have to put it at the end of your program. If you put it here, I'm sure some students are going to make this mistake. Please don't put it here because we don't write code here. Here we only write equate. So this file was okay to put it here. However, yeah, so you have to write this way here at the end of your program. Okay, you have to put it this way. Okay. Any question? I think it should be very clear now to do it. One more thing here also, I'm telling you, you have to define a variable called counter. Okay, this way as I'm explaining here, because I'm using in these subroutines, I'm using this variable. So if you don't, if you forget to do this, code is going to give you error. Is going to tell you you are using a variable, but you did not define it. You are going to be confused. Why? Because you didn't use the variable in your program, but it is already in the subroutines. You got what I'm saying? So anyway, so you have to define the variable. So anyway, you have to the tutorial here. It should be very easy to do. Okay. So let me summarize what I said. So what I'm saying is that from now on, okay, everything we did before for assembly, you are going to do the same thing. Okay. So you are going to create a new project similar to what you did before. You have to select your processor similar to what you did before. However, there are two new things you have to do. Okay. Number one, you have to include this file, as I explained right now. Number two, don't select simulation because we are not going to work on simulation anymore. So please, I'm quite sure in the coming lab, many students are going to make this mistake. If you put here simulation and you run your program, you're not going to see anything on the board because you are working with the simulator. Okay. So starting from the coming lab, you have to select here, guys, serial monitor. Serial monitor here means you are gonna work on the board itself. Okay. And also in lab one, I'm explaining in details how can you work on the board not the simulation. Please check lab one just to make sure you can the board can communicate with your laptop. It's connected to your laptop. Any questions? So I explained this one last time. All what we did here in this program, it was just a very easy program. As you see here, guys, number one, I pull one pin high, as you see here, using bit set. Then I'm gonna wait 1,000 millisecond, which is one second. Then I'm gonna pull the same pin low. Again, high means 5 volt. Keep in mind, here we are in this course, similar to any digital system, we are binary, either 0 or 1. 0 means 0 volt. 1 means 5 volt. That's all what we have. We don't have any other volts, 0 volt or 5 volt. So here, using this instructions with this pin, external pin, you actually put 5 volt. And because there is, when you put 5 volt here, you actually turn this LED on. That's why you can see it on. Okay. And then here you turn it off. You wait 1 second, and then you turn it off, and then wait 1 second, and then you keep repeating. Actually, what you did here, yes, you are going to see flashing. But actually what you did, you generated a square wave. You generated a square wave because if you look at the voltage on this pin, that's what you will see. So if you connect this pin to the scope, that's what you are going to see. You are going to see this is 1 second. It's 0 for 1 second. It's going to be here 1 or 5 volt for 1 second. 0 for 1 second, 5 volt for 1 second, square wave. And that's exactly what you have to do in the coming lab. In the first part of the coming lab is very easy because this is the first time we use the board. So it's just a simple, the coming lab is just a simple modification to this program. Okay, this is the first part in the lab. So all what you have to do, number one, you already have the program. Run it. Just make sure it's working. So you already have the program. And I tested all the programs. I posted in the course website. So I am sure they are working. Okay, all what you have to do, just test this program and then make simple modification. What modification you want us to do? I'm going to tell you. For example, here, guys, I'm going to ask you, for example, to generate a signal this way. For example, this one 1 second and this one 4 seconds, for example. Okay, so all what you have to do, look how it's very simple. Just you have to play in this number here. That's it. So this is 5 volt here. So if I wait here, if I put here 1000, that means the high is going to be 1 second. If I want to make the low, 4 seconds, all what I have to do here, just write 4000 here. Is that okay? So very easy. So by changing the delay time here, you can generate different signals. Okay, so you can even generate a signal something like that. Okay, here in this one, that's the signal we generated, 1 second here and 1 second here. And in this case, by the way, we call it the duty cycle, and you should learn what I mean by duty cycle. So duty cycle is 50%. What is the definition of the duty cycle? Very simple. The duty cycle is this one here. We call it T on or T high divided by T, the period T. Okay. So when it is 50%, that means the high is 50% of T. So 50-50. So 50% here and 50% here. Is that okay? If it is 10%, so in this case, or if it is 10%, it may look something like this one. So this one is just 10% of the period. Okay. If it is 90%, you should see something like that. So this one here is 90% of this one. Okay, that's it. So in the coming lab, all what I'm asking you to do, number one, you have to modify this simple program in order to generate different square waves. Is that okay? Very easy. You have to start with this program. I am sure the program is working. So you just run this program, make sure it's working, and then after that you can modify. Okay, guys? Any questions? So now what I'm gonna do right now, guys, I'm gonna explain the same program right now, but using C instead of assembly. And also I'm gonna explain, because this is the first time you are gonna write a C program. So I'm gonna also explain how can you do that. Okay. Any questions? Okay. For C language, I already make also. I know. So C language is a prerequisite for this course. So I'm not gonna use very advanced C language. I'm not gonna ask you to write like classes, structure, something too advanced. So if you only know the basic of C language, you should be okay. Like for loops, while loops, arrays, and functions. So you should be okay. However, I know some of you may not like C language. Maybe some of you already took C language long time ago, whatever. That is why I make here a revision, and I went through this revision quickly last time. You have any gap or any problem you have in the basics of C language, you already have a revision here. Also, if you search online, especially on only we are gonna, I don't need very advanced C language, so you should be okay. But any problem you have about how can you use C language, you can search online. Also, you can find it here in this file. Okay. Now, so last time also I made like very quick revision. Or I explained several maybe new stuff in C language you didn't need to use before because you didn't program maybe some of our you did not do like big programming in C language before. So for example, here I explained this one here, guys. This is logic AND. This operator. This is logic AND, bit by bit logic AND. Is that okay? Please don't be confused between this one and between this one. They are completely different. They are completely different. This one is used, for example, if you want to make a condition inside if or inside while, whatever. So you can put a condition A, for example, greater than 2 and A less than 10, for example. Okay. So here, here, this is the whole, everything here is like one condition. So I wanna execute the body if this condition is true and this condition is true. So this AND is different from this AND. This AND is bitwise AND, bit by bit. Yes. Say it again, sorry.
You know how parentheses multiplication?
Yes. Yes. Yes, that's what I'm gonna explain right now, because we got a problem before. I'm explaining it here. Okay, so for here here this is the issue I explained last time. Here you wanna do this and then you wanna compare the result with this number. However, in C language, this conditional equal, or this equal, actually it has more priority. So what's gonna happen here, as I explained last time, is you are gonna evaluate this one first, and then you are gonna do this operation second, because this one here, it has more priority than priority than this one. Okay, so in order to solve this issue, I told you have to use parenthesis here in order to solve this one first and then do this one. You got what I'm saying? So again, I think this is the main problem we're going to have here regarding the priority of the operation, because maybe it's somehow a surprise that they put. But anyway, this one has higher priority than this one. But anyway, we can just put parentheses here. Otherwise, it may not work. Same thing here, guys. This is logic OR. Okay, one more thing before I leave this one. As I explained in chapter 2, okay, how can you use logic AND? As I explained in chapter 2, we use logic AND in order to clear some bits, and I think I made it. Same thing we are going to do it here. You are going to use logic AND if you want to clear some bits. Okay, you can do something like that. As you see here, I can say port B equal to port. Sorry, this is we can do something like that. Okay. So here, port B, it's a byte, port B, this is port B, and then you do AND operation with this number, which is 111, and then 1110, okay? So when you do that, as I explained in chapter 2, actually you are gonna clear the bit you wanna clear, you have to put 0 here. The bits you don't want to change, you put 1 here, as I explained before. So please understand this, because we are going to do it all the time. All the time we will do this. So here, if you want to clear one bit, you have to do it this way. Okay. Okay, guys. So we are gonna do use AND this way. Okay. Also, we have here OR. We have OR, but it's the same thing, bit by bit OR, this one here. And as I explained before, we use OR operations if you want to set some bits. So this one is used if you want to set some bits. Is that okay? And that's exactly what I'm doing here. So here, this is port B, and then you are going to put 40, so 0000, and then 0010. So actually, you are going to set this bit. And the other bits you are not going to change. So, okay, so I already explained this one many times. So I'm going to use it here simply because in C language you can do the same thing as I explained right now. You can use logic AND, logic or there is an easier way, as I in assembly language, there is an easier way. You can simply use bit set and use bit clear. This is much easier way in my opinion. Or as I explained in chapter 2, you can use AND or. However, in C language, this is the only way you have to do it. So if you want to clear some bits, you have to use this statement. If you want to set some bits, you have to use this one. Okay, guys. One more thing, as I explained before, in and also it can be used if you want to check some bits. If you want to check some bits, if it is 0 or 1, and this is the example I'm giving you here. For example, here, this one here, we have port H. So this is PTH, port H. And then I'm going to do AND, logic AND with, so the bits you don't want to check, you put zeros, as I explained before. So here should be 0, 0, 1, 0. Okay? Because you put 0 here, so I'm sure all of these bits are going to come, they are going to be zeros. Okay? And then we have here bit 1 and 0. Is that okay? So this is the result I'm going to get. Okay? So here, I want to check this bit. That's why now I have a byte. This byte, all the bits are zeros except only this bit. Okay. So now I can check this byte. If this byte is equal to 0, what it means? It means B0 is equal to 0. Or if this byte is equal to 20, sorry, 02, sorry, 02, okay, that means B1 is 1. Okay, again, this is this is exactly same thing I explained in chapter 2, but I just use a different syntax comparing to chapter 2. Okay, so we're going to do this one also all the time. How can you check some bits? Is a very easy thing. Okay, again, don't be confused between this one is completely different from this one. Okay, as I said before. So this one is used in case if you have a condition. For example, if A is greater than 2 and B less than 5, something like that. So this is condition, and the relation here is OR. Okay, so this is not bit by bit operations. Same thing, I explained this one, XOR, and I explained in chapter. So this one means XOR. I explained in chapter 2. XOR is used if you want to flip some bits. Okay. So this one for shift right, this one is for shift left, this one for not complement. Okay. So here also I give you example. For example, I can say port B is equal to port B shifted right 3 times. This number can tell you how many times you shift. We didn't have something like that in assembly. In assembly, every instruction is going to shift only 1 time. So if you want to shift this 3 times, you have to write it 3 times. You got what I'm saying? But that's okay. But here you can tell how many times you can shift here. Okay. Yeah, this should be easy part. Okay. Also, similar to what we did in assembly, it's very close. Okay, similar to what I did. If your number is hexadecimal, you remember we put a $ in assembly. Here we're gonna put 0x. Is that okay? We put percent in assembly. Here we are gonna put 0p. So 0p means the number is binary. So if the number is decimal, you don't put anything. Yeah, same thing here in C language as well. Any question, guys? Okay, great. So now let's come to how I can write the same program in C language. How I can do it. Okay, look here, guys. It's the same everything I did here. So for example, everything I did here, I can do it in C language, but you have to use different syntax. For sure, you understand the syntax of assembly is different from C. Okay, for example, what this instruction is doing, this instruction should copy FF to DDRB. Is that okay? If I want to do the same thing, okay, in C, so how can you do it? Okay, very simple. All what I'm going to do in C language, guys, I'm going to say DDRP, okay, should equal to 0x, okay, instead of $0x, FF. That's it. So this one is going to be exactly equivalent to this one. That's it. Okay. How can you set? But we don't have a bit set. Yes, we don't have a bit set. That's why you can use, if you want to set a bit, you have to use logic OR. Here, you have to use logic. You have to use logic AND. Okay. And for delay YMS, we have an equivalent function in C you can use. Okay, guys. So what I want to say, guys, right now, what I want to say is the following. What I want to say, the C program I'm going to teach right now, it will be similar to this one, but I just use different syntax. Is that okay? So for example, yeah, let me teach it here. Okay. So look here, guys, as we did in the C language, sorry, in the assembly language, and we have always to do that, as I explained to you before. If you want to use any input-output device, you have to program the port. The port is input or output, and this programming should be done only 1 time. Okay, that's exactly what I did here. Look here, guys. Data direction registered for port B equal 0xFF. So here I'm programming port B. Port B here is output. Okay. Here I'm programming port J output. I'm programming port P output. Is that okay? So here, and also I'm programming, I'm writing 0 to port J, PTJ. Okay, guys? So port J, the whole port of J should be 0, 0, 0, 0. Is that okay? PTP Here I put 1111 in BTP. Okay, very simple. So you can do it this way. However, listen to me, because this will be an issue in the next lab, not this week, but next week lab. Listen to me. So what I did here, guys, remember here, I only care about PG1, right? I just want to put one only in PG1. That's okay. So what I did here, sorry, I want to put 0 in PG1. So what I did here, just I put 0 everywhere in port J, everywhere, put 0, 0, 0. Okay, it's not gonna hurt me in this program because the other bits in port J are not gonna interfere with my program here. Okay, so it should be okay. It's not a big deal. Okay, same thing I did here for port P. In port P, as I told you before, what you have to do, guys, I just care about the first 4. PP0 to PP1, because these are connected to the 7th segment. So I only care about this one, 1, 1, 1, 1. Is that okay? Just to make it easy, I just wrote once everywhere. However, this will be an issue in the coming lab. Why? Because in the coming lab, these bits here, now I'm going to use them for the RGB LED. You got what I'm saying? So if you use something like here in this program, it's okay because I'm not using these bits. So if you just put once, it's not going to hurt in this program, okay? But in the coming program, it's gonna interfere with the RGB because I'm going to use these bits. So you cannot just put once this way, otherwise you are going to have a trouble in the coming lab. Okay, so you are telling us you just want to make it easy, you just put 1, 1, 1 here, okay? Because you are not going to use the RGB, so you don't care about what you are going to put here. Yes. So, but in the coming lab, you have to be careful about this one. You have to be very accurate. That means if this is port P, you have only to change this part, and you should not change this part. So you have to put here 1, 1, 1, okay? And just don't change these ones, okay? Not like what I did here. How can you do that? Very simple. How can you set some bits using XOR? So instead of using this one, guys, I can say PTB should equal PTB. Again, in this program, it's okay, but in the coming program, because I need to use these bits, if you write something there will be, you will see interference between the 7th segment and also between the RGB. Okay, anyway, so instead of writing this way, I can say BTB equal BTB or, and then here you can put 0B, and then here you put 0, 0, 0, 0, because I don't want to change this one, and then you put 1, 1, 1, 1. That's it. So that's what this one is more accurate. Okay, if you make it this way. So I only care about the first 4 bits. So I should have only manipulated these bits. Okay. Same thing here. You can do the same thing for BG1. Instead of writing to the whole port, you can just say, BTG equal BTG. Here you wanna clear. If you wanna clear, so you have to use end, and then you have to use here 0B. The bits you don't want to change, you have to put once. I'm gonna put here 4 once, and then 1, 1, and then I'm gonna put 1. I'm gonna put 0 here. Is that okay? So here I'm gonna manipulate only 1 bit. Anyway, so this is so similar. All what I want to see here, guys, if you look at these instructions, and if I go back to the assembly program, so I just want to make it easy. So I'm saying these instructions are just same thing I did here, same thing, but different syntax. Exactly same thing. Is that okay? Okay. Now I'm gonna do also same thing right here. So I need infinite loop. How can you do that in C language? Very easy. I can say while 1. So while 1 can make an infinite loop. Okay, so that's exactly what I'm gonna do right now. Okay. Yeah, as you see here. Okay, guys, infinite loop. Similar to what I did here, exactly same thing. Number 1, you have to turn the LED on. You have to wait 1 second. You have to turn it off. You have to wait 1 second and keep repeating it. Is that okay? I'm going to do the same thing, but in the syntax of C language. Okay. So as you see here, guys, that's exactly what I did. So here I can say port B equal port P and 02, for example. Okay, so if I do this one, guys, so here that means I'm gonna put here in bit number 1, I'm gonna put here 1. So I'm gonna turn this LED on. Okay, don't be confused. Maybe the other program I'm using, I'm putting 1 here. So I'm flashing. That's okay. If you are confused, I can make this 1 instead of 2. Okay, so here in this program, I'm flashing the second LED. I think the other program, I'm flashing the first LED. So it's not a big deal. Anyway, okay. So using this instruction, I can just put 1 here. Okay. Also, we have here instruction, we call it ms underscore delay. This function is similar to delay YMS, but in C language. So this function similar to this one, guys, but this is the assembly version. The other one is the C version. Okay, so here, as you see here, so whatever you put here, so I'm gonna make a delay 1000 milliseconds. Is that okay? So here I'm gonna wait. Then after that, you have to turn it off. I'm gonna turn it off by using AND, logic AND, to put here 0. So I'm gonna put here 1, guys. Wait 1 second, then put 0. Wait 1 second, put 1. Wait 1 second, and so on. Keep repeating as you see here. Is that okay? Again, very easy. If you understand the assembly, what I didn't do anything new. I just used different. I just used the C syntax. I did everything I did before for assembly, but I just use the syntax here. Any questions? So I can use this ones here, and then I can use this one here. Is that okay? Now let's come to a very important topic for you. C language, or the way I did it here, guys. This is like low level. Yes, you did it in C language, but it is like low level language, low level programming language. Why? Because I put details. I put here the detail. I put port B, port J, port P, J, whatever. So here I put the details. So this would be okay in assembly, but it would be like some kind of weird. It's weird to do that in high level programming language because you put the details. Okay. Again, it's okay. You can do this way. I'm not saying it's wrong. What I'm saying, usually in high level programming language, I want to hide the details. You can program the microcontroller without even knowing where the LEDs are connected to which port, without even knowing anything about ports. I want to hide details. Okay, this is usually what we do in high level. Again, for this course, it's okay to use this way, but I just want to explain to you guys. In low level programming language, you cannot program microcontrollers if you don't know the details, if you don't know where the LED is connected and so on. Okay. For high level programming language, I can program it without knowing the details. So how can you do that? Usually we do it using functions. That is why that's what I'm going to explain right now, guys. That's why in C language, we have functions. Okay, we have functions. We have many functions, and you can just use these functions. Okay, without knowing any details here. Again, if you want to use this one here in this course, I'm totally fine. If you think this is easier for programming and you want to use them, I'm totally fine. So the conclusion I want to make here, guys, the conclusion is in C language, you can program it like assembly. You can do all the details. Okay, you can do all the details in this code. Okay, or you can just use functions, and these details are hidden. These details are hidden inside the functions. Is that okay? For example, that's exactly what I'm saying here. So what I'm saying here, guys, what is the purpose of this code? If you remember, the purpose of this code is to enable LEDs and disable 7 segment. Is that right? This is the purpose. Okay. So that's why we made 2 functions this way, as you see here. We have a function we call segment 7 disable. So if you use this function, so inside this function, you will find, if you go inside this function, you'll find this one, and you'll find this one. So these two are inside this function. Is that okay? That's why I hide the details. And LED enable. So if you find this one, this one, and this one. These three are here inside this one. Okay, guys? So, and functions, I'm totally fine. You can use functions. However, function made some trouble for us before. For example, I think it's written this way inside this function, I guess. Okay, that's why, as I told you in the coming lab, we're going to use RGB. So there was a problem using this function. So anyway, so what I want to see here, guys, listen to me, please. Don't be confused between what I did in assembly and what I did in C. This is a very important thing. What I did in assembly, I wrote many functions. I put them in one file. You include the file, and you can just use this function. Is that okay? What we did here in C language, is we made many functions as well. We made many functions in C language, and these functions are written in assembly, and I call it from C language. Yes, you heard it correctly. So this is one of the things C language allows us to do. In C language, you can write function in assembly, and you can call it from the C language. So all these functions, okay, all the function I'm gonna use here in C language, they are written in assembly, and you can just call them from the C language. Is that okay? So here in the course website, let me go to here. First of all, if you see here, guys, I make a summary for all the C functions we have because there are too many functions. So let me show you this one file as well. Yeah. So here, guys, this is the summary for all the function we are going to use here in the chapters, in chapter 3, 4, 5. So here, this is the function, and this is the description. Okay, just I make a summary to make it easy for you. Okay, this is number one. I posted here. Okay, one more thing I posted here is here, guys. This one, I told you I can write function in assembly, and I can call it from the C language. Okay, so here I give you a tutorial. How can you do that? So the way you have to do it, I'm explaining it here. Okay. By the way, before I explain how can you do it, please listen to me because that's a very important thing. As I explained, starting from the coming lab for assembly, what you are going to do in assembly is going to be exactly similar to what you did before. Number one, you have to create a new project. This number one. Number two, you have to include the file subroutine. Number three, please don't use simulation anymore. Use serial monitor. This is what you have to do in assembly. However, what you have to do in C is different. I'm going to tell you why. In C, please don't create a new project in C. Why? Because if you create a new project, you are not going to find the functions we are going to use in C language. Okay, so how, if I don't do like C, create a new project in C, similar to what I did in assembly. So how I'm gonna run it? Yeah. So the way you have to do it, guys, in the course website, I post a project for C language. Inside this project, I program all the functions we are gonna use in C language. You got what I'm saying? Again, let me say it again. So all what you have to do, guys, in C language, please don't create a new project in C language. Because the function I'm going to teach in chapter 3, 4, 5 are not coming with code warrior. This function, I made them, okay, using assembly, and then I just call them in C language, okay? So that is why for C language, I post on the course website a project. All what you have to do every time you want to run a program in C language, please use this project. Otherwise, code warrior is going to give you error every time you use a function. It's going to tell you, what's this function? I don't know this function. You got what I'm saying? So I'm going to give you details now, but let me go again to the course website. So look here what I wrote, guys. The project you have to use to run C program because it has all the C function we teach. Is that okay? So you have to use this project. Here I'm giving you a tutorial how, yeah, the tutorial is here. This is a tutorial. Let's see the tutorial. What you have to do. Number one, guys, from the course website, you have to download this program, zip file. And then you have to unzip it. Okay. After you unzip it, you are gonna have, this is the project I'm talking about. So I'm talking about this project. Okay. This project, I'm gonna show you where this project has all the functions where I'm gonna teach in C language. And they are written in assembly. Okay. That's what I'm gonna show. So all what you have to do, guys, if you wanna run a program in C language, every time you have to use this project. Every time you have to use this project. Yeah, the way you have to do it, as you see here, you have to run the program this way. Once you run the program this way, guys, you can see here, you have main.c. Okay. This is where, so all what you have to do, you have to remove this part here and then put your program here and run it. Is that difficult? What I said is difficult. So let me say it again. For C language, number one, don't create a new project in C language. Assembly is okay. C language, no. Right? In C language, every time you want to run it, open this project here. Once open this project, just main.c, write the program here in C language. But why? Why should do that? Simply because I'm going to show right now, this project has all the function I'm going to teach in this course. Okay, they are defined in assembly. And if you want, and sometimes we need to do something like that. If you want, you can go inside this function in assembly and you can modify them if you want. Okay, I'm going to show you as well. But so let me, okay, so all what you have to do, guys, every time you want to run a program in C language, you have to come here to main.c, then you write your program in C language here, okay? Also in this tutorial, I'm explaining what if I want to make a new, what if I want to make a new function in assembly and I call it from C language, how I can do that. Here I'm explaining what you have to do. So you have to go to this file .sm, you have to make a definition here, and you have to go to this file, you have to put the function here, and so on. And you have here, this is, if you go to main.sm, you can see all the functions here are written in assembly, okay? However, in this course, I'm not gonna ask you to write a program in assembly and call it from C. I'm not gonna ask you to do that. Is that okay? So all what you have to do, guys, how you should learn how can you use the functions I already defined here, okay? And you may need, I think in maybe 1 or 2 cases, you may need to modify some of the functions here. So you may come here and instead of bit set DDRG02, maybe you need to go and change this one. Maybe, okay? But I'm not gonna require something like that. Okay, guys? Conclusion. For C language, don't create a new project. For your C language, you already have a project on the course website. You just open it, go to main.c, and then write your program there, run it, everything will be okay. But why you made this way? Simply because I have some functions in C language. These functions are defined in this project. They are not coming with code warrior. They are defined here in assembly. And you can go and see this function and try to understand the assembly, okay? And if you need, you can just modify them if you want, okay? Anyway, here if you want to create a new function different from what I'm teaching, if you want to create a new function, I'm teaching how can you do it, but I'm not going to ask you to do it, okay? I'm not going to ask you to make a new function. Any questions? Okay. So now, guys, what I'm saying is here, guys, if you want to do it here, like assembly this way, okay, that's okay. I'm totally fine. In a different way, you can just use functions. So I'm going to teach you some functions here. As you see here, the first function here I'm going to teach you guys is 7-segment disable here, okay? So this disable, actually this one is going to disable the 7 segments. So this one is going to do this one, and also is going to do this one as well, okay? And you can, again, as I explained in the tutorial, you can go inside this function and see what is written there, okay? It should be written in assembly, okay? Same thing here. So every time you want to use the 7 segment, you have to use this one to disable the 7 segment. You have to use this one to enable the 7 seconds. That's it. Details are hidden. If you want to understand the details, so inside this function, you will find this one, and also this one. Okay. Also, here, port B equal port B 02. So here, what I did here, I just put one here. I put one here on port B. Okay. There is another way to do it. There is a function. This function is called LED on. And then you have to tell me which LED you want to turn on. That's it. So that's what I'm saying. I can hide the details. You may not even need to know that the LEDs are connected to which port. You don't need even to know that. If you want to turn on LED number 1, just put here 1. If you want to turn LED number 2, just put here 2. That's it. So functions can hide details. And that's why I'm saying this is more like high level. I want to hide details. But anyway. And then we have another one, Ms Delay. And any time here, this one can make a delay, and any number you put here is gonna be this number in millisecond. We have another function, we call it LED off, as you see here, LED underscore off. Okay, so here when I put 1 here means the first LED is 0. We start from 0 until 7. Is that okay? So here if you put 0, so it means I'm gonna turn LED 0 on, but here I'm going to turn number 1 on. I'm going to turn number 1 off. This is for on. This is for off. Any question, guys? To understand that in C language, I'm going to teach functions. These functions are written in assembly, and you can see and go up and you see how they are written in assembly. But you should also understand in C is not high level. I don't need to worry about the details, right? That's why I'm going to use function. If you want to do something, just use this function and forget the details. You got what I'm saying? Anyway, but still, I give you also you can do details if you want. Okay. Yeah. So this is the summary of the function I taught right now. So we have here delay. Ms delay, okay, this can make a delay in millisecond. We have also US delay, microsecond delay, LED on, LED off, okay. Any questions? Okay, great. So now I'm gonna move to another program because also you are gonna need this program in the coming lab. In this program, I'm going to teach how can we do serial data or serial communication. You know what I mean by serial? When you send data serial, what it means serial? Serial, it means it's just one pin, only one pin, serial, one pin. So in this pin, I can send the bits 0, 1, 0, 1, 0, 1, okay? As you see here, so it's only one pin, it's only one pin. So here, you can see 0 for some time, and then 1 for some time, 0 for one time, 0 for time. This is the data. You are sending the data serial. So every certain time, you send 1 bit. Certain time, you send 1 bit. Is that okay? So I'm going to teach how can we do something like that in C and assembly. And if you connect this one to the scope, you should see something like that. As you see here, this one should be 0, 1, 0. As you see here, guys, 0, 1. 0, 0, is that right? And then 3 ones, right? Yeah, 4 ones. 1, 2, 3, 4. So this is a data serial, okay? And I'm gonna keep repeating it in order to see it on the scope, because if you don't repeat, in reality you are not gonna repeat. In reality, once you send the data, okay, so there should be another side. The other side should receive this data, right? But what I did here, guys, this is my information. I want to send 0, 1, 0, 0, 1, 1, 1, 1. Okay. However, I'm going to keep sending it in order to be able to see it on the scope. You understand what I'm saying? If there's only one time quickly, so you cannot see it in the scope. So what I did here, guys, I repeat it again, so that I can see it in the scope. Okay. Again, guys, you should understand what you should learn in this program. Number 1, how you are going to send the data serial. You should understand what serial means. We have one pin. If you look at this pin, every certain time, you are going to get 1 bit. Okay, 1 bit. Serial. Is that okay? Also, you should I'm going to teach how can you do it. Also, you should understand that I am going to repeat it, not because of functionality. I don't need, in reality, if you have transmitter and the receiver, in reality, you are not going to repeat, okay? But I'm repeating it just because to be able to see it on the scope, okay? So now let's see how I'm going to program it, okay? So here, guys, I want to send this code. I want to send this information on this pin, PT0, okay? Please, in the coming lab, again, you are going to use the same program here. You are going to do a very little modification to this program. I told you the coming lab is very easy because this is the first time you use the board. This is the first time you use C language as well. So it's the first time you use C language. So that's why I make it easy. That's why if you read the lab, you will find it's just modification to this one and modification to the other program. Okay, so you have to run this one first, make sure it's working, and then you modify it. So what you, but here, I'm going to send this data on in PT0. Remember what PT0 means? PT0 means it's port T, bin number 0. Is that okay? However, in the lab, I'm going to ask you to do it in PB0, I guess, so that you can see this information on the LED. PB0, this is where the LED is connected. So this is the change you have to make. If you run this program, you are not going to see anything unless, why you are not going to see anything? Because this number are going to be on PT0 and the LED is not connected to PT0. Is that okay? So if you want to see something like that, you have to bring a scope. If you want to see something like that, you have to bring a scope, and the scope you have to connect to PT0. Also, don't forget this important thing. You have to connect this other one to ground. So the board of the ground has to be connected to the board of the scope. Both of them, the same ground should be connected, and the other one should connect it to PT0. So where is this ground on the board and where is PT0? I'm going to show you here. If you go to here, guys. Yeah. So if you see here, so all the pins are here. So all the pins are here. Okay. So try to see. I think I see here PT4, PT5. So you just can connect it here. I think PT0 is some. Yeah, PT0 is here. So you just connect it here to PT0. Is that okay? And where is the ground? Actually, you have many grounds. So any ground should be okay. So this is one ground. I think you can find many grounds here. I think this is also another ground. Okay. You can find multiple. This one is a ground. All of them are connected together. Any ground should be okay. Okay. So all what you have to do, if you have the scope, you have to connect here to this one, and the ground has to be connected to the ground. That's it. That's how you can see the signal. Okay. But next time, because you may not have a scope, so what I did, I want you to do this one on port B, and port PB0, so that instead of I will try to bring in the coming lab like a couple of scopes, but anyway, just to make the lab easier, you can see this signal. You can see this signal on PB0. You will see the LED is off, on, off, off, on. So visually you can see it. Okay. But for sure you can do the same thing. That's why I'm going to make the delay here. It has to be a long time. The delay here has to be a long time to be able to see it. If I make it 1 millisecond, for sure you cannot see on off every 1 millisecond. So I'm going to make it big, long delay so that you can see it. However, in case of the scope, yeah, you can make it a very short time. Okay, I think this one was very short. I don't remember, but it looks like 2 milliseconds. I guess everyone here is 2 milliseconds. I guess. Anyway, so let's see how this is gonna work here. So I'm gonna teach this program, guys. Again, remember here I'm gonna generate this signal, or I'm gonna send this data serial on PT0. In the lab, I think I asked you to make it PB0. Anyways, it's just a simple modification. Okay. So I'm gonna teach this one, this program in both in C and in assembly. So, and it's already here. So if you open it here, you can find it here. Okay. So let's see how we can teach it. How can we do this one in assembly first? Look here, guys. You have a byte. So this information is stored in a byte. It's like, for example, 0, 1, 0, 0, 1, 1, 1, 1. Is that okay? And then all what I can do now, I need to output 0, output 1, output 0, output 1. So how I can do it? Yeah, very simple. All what I'm gonna do, guys, I'm gonna make shift left shift. So once you make shift left, so this bit is gonna go to the carry. Okay. Then I'm gonna ask the carry. So here I'm gonna make shift left. So once I make shift left, so one bit, this bit here, I'm gonna put the carry. And then I'm gonna ask the carry, are you 1? If yes, the carry is 1. So I'm gonna set this pin. Okay, so I'm gonna set this one. If the carry is 0, I'm gonna put here 0. So I'm gonna keep doing that. So as you see here, guys, number 1, I have a memory location. I call it P, and then I'm gonna store this number in this memory location as you see here. Okay. Also, don't forget. Please don't forget. Okay. Before using any port, you have to program this port, input or out, only one time. Okay. That's what I did here, because I'm gonna use data direction register port T. So here I have to program this pin PT0 here. I have to program it input or output. In case this case has to be output. As you see here, guys, number 1, I'm gonna shift. Then after I shift, so I'm gonna take 1 bit. I'm gonna take 1 bit to the carry. Then I'm gonna ask the carry, branch if carry is set. If the carry is 1, so I have to output 1. So that's why I'm gonna come here. Otherwise, if I come here, that means the carry is 0. So I have to clear the bit, right? So how you made it? Very easy. Look here, guys. Yeah. So if the carry is 1, so I'm gonna say bit set PTT. Otherwise, I'm gonna say bit clear PTT, as you see here. Very easy, right? However, there is one small issue here. What is the small issue? I told you I want to generate this code. I want to generate this code continuously. It's not only one time, continuously. Okay, so there is a problem here. What is the problem? After 8 shifts, you are going to get 0, 0, 0, 0. Is that okay? After 8 shifts, you are going to get 0, 0, 0. So I want to do something like what we did in the last lab. So I want to do something like this way. So every time I get a bit here in the carry, the same bit has to come here. So that after 8 iterations, after 8 shifts, I'm going to get the same number again. Okay? How can you do that? Very simple. All what I'm going to do, guys, here, look. After I shift, if the carry is 0, I'm going to do two things. Number 1, PT0 should equal 0. Okay, the carry is 0. I have to output 0. Number 2, I have to put here 0 as well. You get what I'm saying? It's like rotated. So that after 8 iteration, I'm going to get the same number again. Okay. If the carry is 1, okay. So what I'm going to do, I have to output 1, and then I have to put also 1 here. Okay. So that after 8 iteration, you are going to get the same number again. That's exactly what I did here. Look here, guys. Again, number 1, I'm going to shift. After you shift, if the carry is high, go to high. When I go to high, I'm going to do 2 things. Number 1, PT0 is equal to 1 using this one. Number 2, here, I have to write here 1 as well. Okay, it's like rotate. So that after 8 iteration, I'm going to get the same number again. So I did it this way. Okay? So if the carry is 1, I'm going to come here. However, if the carry is 0, so I'm going to come here if the carry is 0. So if the carry is 0, again, I will do. If you look at this one, guys, it's identical to this one. The only difference is here bit clear, here bit set. Bit clear because the carry is 0, bit set because the carry is 1, right? Then after I come here, I have to put some delay here. I didn't put it here, but yeah, you have to put some delay here. This delay should be this delay here. So I already output 0, so I have to wait for some time. I have to output 1, then I have to wait for some time. Is that okay? So if you want to wait for 1 millisecond, okay, so you can put here 1 millisecond. If you want to wait for 1 second, so here you can use the function delay YMS. Is that okay? Then after that, you can loop back here. So all the time I'm going to keep looping here. Okay, So let me clear everything. So if you see here, guys, oh, sorry. So here I'm gonna keep looping. I'm gonna keep looping forever here. Okay. Every time, number one, I shift. Number one, I shift. Number two, if it is high, go to high. If the carry is high, if the carry is zero, come this way. If the carry is zero, again, I have to do two things. I have PT0, please pull zero, or pull low, or make it zero. And then here I have for memory location P, I have to put here zero. Okay, same thing for this one. And then I have to wait for some time and keep repeating. So every iteration here, I'm gonna output only one value in every iteration, one value. And every 8 iteration, I'm gonna get the same number again. That's why I'm gonna repeat it. Any questions? Okay, guys. Again, I think what you have to do in the coming lab, I told you if you have discovery kit, maybe some of you don't have it. This discovery kit like a scope. You are using your laptop as a scope. Okay. So in this case, you can make a small numbers here, and then you can see it on the scope on discovery kit. I'm gonna bring a couple of scopes just in case if you want to see it on the scope, right? However, we can do the same thing and make it visible by your eyes. You can see it by your eyes using the LED. So what you can do here, instead of PT0, this one is going to be B0, but I'm going to make the time here long time. I'm going to make it long time. Long here means 1 second, 1 second, half a second, something you can see. If this time is 1 millisecond, you're not going to see anything too fast, right? Anyway, any questions? Great. Any questions? Now, let's see how can we do the same thing using C language. Okay. Again, you have the program here on the course website. Okay. I'm gonna teach in C language. I can use exactly the same idea I explained here, so I can use the same idea, but I decided to have a different idea. Why? You know, in programming, it's a good idea to like learn different ways, right? So I'm gonna make the same thing here as I did here, but I'm gonna make it a little bit different. Okay, in a different way. I'm gonna do the same thing, but somehow a little bit different way. Okay, but still I can do this way. But just I want you to learn different ways. So the idea here I did, guys, as you see here, I have here what we call we have data type in C language is called the byte. Byte is used if you want to define a byte. So here I define a byte pattern, and this is the pattern I want to generate. Okay, that's what you have to do. Also, just here you have to program. You have the direction register, guys. You have to make sure, because I'm going to use PT0. You have to program PT0 as output. So this is the way you have to do here. Is that okay? And then I have infinite loop here. Infinite loop. Yeah, it's exactly the same thing like this one. Also, you have infinite loop here. Yeah. And in every iteration, as you will see right now, I'm going to check if the bit is 0 or 1. If it is 0, I'm going to output 0. If it is 1, I'm going to output 1. And then I can also add some delay here. Delay. Okay. So let's see how it works, guys. But the way I'm going to do it here, little bit different from what I did before. Look at the idea. The idea is that this is better. This is better. Okay. So I'm not going to change this number. So this number is fixed all the time. I'm not going to shift this number. This is different from what I did before. Okay. Again, guys, just I want to teach a different way. Still, you can do the same thing I did before, but I wanna teach a different way. So here, what I'm saying here, guys, I'm gonna also have here something we call it a mask. So what is a mask? In this mask, as you see here, 80. 80 means we have here 1, and then we have 0, 0, 0, 0, 0, 0. Is that okay? Then all what I'm gonna do, guys, I'm gonna check this bit, if this bit is 0 or 1. How? Using logic AND. Is that okay? So here, this mask, the 1 is here, and everything else is 0, right? When the 1 is here, and then I do AND, so I'm using AND, logic AND, I can check if this bit is 0 or 1. Once you know if this bit is 0 or 1, okay, so you can output 0 or output 1. Is that okay? This is in one iteration. Next iteration, I'm going to shift this one to the right. So the 1 will be here. the one. This is in one iteration. Next iteration, so I'm gonna shift this one. So the 1 is here and the 0 is here. So now I'm gonna check this bit. Next iteration, so in every iteration I'm gonna shift it to the right. Okay. So next iteration, the 1 is here. Next iteration, the 1 is here. So every time, every iteration, so this mask, always it has one bit, 1, and the other bits are zeros. The 1 is at the location of the bit I want to check, it's 0 or 1. Every iteration I'm going to shift. Once you shift it to the end, so once you shift it all the way, you are going to get 0, 0, 0, 0. So you have to bring it back to repeat. Okay. So once the mask is equal to 0, 0, 0, that means you shift it 8 times. So I have to bring it here. That's exactly what I did. So look here what I did, guys. In every iteration, I'm going to shift the mask. Again, you should understand what mask is doing. What mask is doing, all the bits are zeros except only one bit is 1. This is the bit I want to check right now. Okay. And then if 1 is here, so I'm going to check this bit. Next time I'm going to shift it so that I can check this bit. Then I'm going to check this bit. Once we shift it all the way, so I have to repeat again. So that's exactly what it. So look what I did here, guys. Yeah. So what I did here, as you see, in every iteration, I'm going to shift mask as you see here. Okay. So after you shift mask, if mask is equal to 0, that means you shift it all the way. Please make it 80 again. 80 means 1, 0, 0, 0. Just to repeat again. Is that okay? Also, as you see here, guys, in every iteration, I'm gonna check. I'm gonna check one bit, as you see here. So I'm gonna do AND, logic AND. Okay. I'm gonna check one bit and see if this bit is 0 or not. Okay. If this bit is 0, what should I do? If the bit is 0, yes, please, you have to output 0. If this bit is 1, please, you have to output 1. And then wait 10 milliseconds. Okay. So let me say it again. As you see here, guys, number 1, I'm gonna check the bit pointed by mask. Mask has only one bit. One bit is 1, the other ones are zeros. Okay. And I change the location of this bit. So I need to check if this bit is equal to 0 or not. If it is equal to 0, I'm gonna come here. If not, I'm gonna come here. So I'm gonna come to here. If the bit is 0, I'm gonna come here. If the bit is 1, okay. If the bit is 0, what should we do? I have to output 0. If the bit is 1, I have to output 1. Okay. Then I'm gonna wait some time. Okay. So this time in the lab, if you want to use in the lab, number 1, instead of port T, you have to make it port B, because port B, the LEDs are connected to port B. This is number 1. Number 2, you have to make the time, the delay, 10 milliseconds is too short. So make it like 1 second or half a second so that you can see the pattern. Okay. Then after that, I'm gonna shift the mask. While you are shifting mask, so I'm preparing for the next iteration. So if 1 is here, when I shift, the 1 will become here. So that in the next iteration, I'm gonna work on this bit. So every iteration, when I'm done with the iteration, I'm gonna shift to next location. That's exactly what I did here. And then I have to check if it is 0. If it is 0, 0, 0, shift it all the way 8 times. After 8 times, so it's gonna get 0, 0. So I have to reinitialize it again, put the 1 here, and then keep shifting. Any questions, guys? Any questions? Let's have more fun. Any question? Okay, let's have some fun. Now I'm gonna teach. By the way, I'm not gonna I'm gonna teach everything in this chapter, but I'm not gonna follow the same order because I want to teach what we need for the lab first. For labs first, it's okay because they are separate topics. Okay, so it's okay to. I'm gonna come back to. So I'm gonna skip this one for now, but I'm gonna come back to it. Okay, so I wanna teach how can we use the buzzer. It's really fun. Okay, so as you know, guys, if you look at the board here, let me go back to the board here. We have a buzzer. Yeah, so this buzzer here. By the way, if you have a sticker, if your board has a sticker on this buzzer, Please take the sticker off, otherwise you are not going to hear it well. Okay, so we have a buzzer here. This buzzer is used to make some sound, Okay, so I'm going to teach right now, number one, how it is connected, how this buzzer is connected. Number two, how can you program it to make sound? Okay, that's what I'm going to teach right now. So this is, you can see it here, this is the buzzer. The buzzer is used to make some sound, right? It's like a speaker, but for sure that's a very simple speaker, buzzer. Okay. Anyway, so let's see how it is connected. And number two, let's see how we can program it. Number one, it's connected to BT5. Connected to BT5, only one pin. So as you see here, the buzzer is connected to BT5. Okay. That means I don't need to say. That means if you want to use the buzzer, you have to program BT5 as output. Yes, one time. I don't need to say it again. Okay. So any port you want to use, you have to program it input or output. In this case, this one is output. So you have to program this one output. Okay, that's okay. So the buzzer is connected to BT5. So now, how I can program this buzzer? How can I make sound? Okay, very simple. So the way you have to make it sound, guys, is on BT5, all what you have to do, you have to generate a square wave. That's it. However, the frequency of this square wave should be in a certain range. What do you mean? I'm going to tell you what I mean. We as humans, our ear can only understand or can only hear some frequencies, right? You get what I'm saying? So you know the dogs and the cats or other animals, maybe they can hear some frequencies we don't hear. Okay. Anyway, so we have a certain. I think you can check online. I think it's between 2K, I think to 20K, I guess, something like that. So there is a certain range we can only hear. So you have to make sure the frequency of the signal you are generating here, you have to make sure it is in this range. Otherwise, you are not going to hear it. You understand what I'm saying? So this is the only thing. Okay. So now you are telling us, number one, the buzzer is connected to one pin. That's okay. You are telling us if you want to generate a sound, all what you have to do, you have to generate a square wave. That's okay. Should be easy because that's what we have done. That's what we have done so far in this chapter. How to generate a square wave. Output 1 with some time, output 0. Yes, so easy to generate square wave. That's true. One more thing, guys. By the way, you know, I'm not good in music, but you know, in music we have different tools. Okay. How if you check the YouTube channel, you will find some students in their project, they use this buzzer to make some music or something, yeah, some kind of music using this one. How they made it, the way they made it, guys, every tune should have a different frequency. You got what I'm saying? So if you want to make a certain tune, generate a frequency. You change the frequency, it's going to be another tune and so on. You got what I'm saying? So very easy. So all what you have to do, guys, just you have to generate a square wave. Okay, that's it. But you have to be careful about the frequency. The frequency should be in the range we can hear. Is that okay? And by changing the frequency, you are going to change the tune, right? That is why I'm going to teach right now how can we make the police siren. Okay? The police siren. Okay? You can see the police siren has two tones. Two tones, right? I'm gonna run one tune. Again, tune means frequency. I'm gonna run one tune for a certain time, and then I'm gonna switch it to the other tune, and then I'm gonna go back to the first tune. That's how we can make the police siren. Okay, so one tune for some time, and then repeat. That's exactly what I'm gonna do right now. Okay. Any questions? So here I'm gonna teach again, programming wise, very trivial. All what you have to do, you have to generate a square wave. Yeah, very easy. Genetic square wave, very easy, right? So here I want to write a program to generate two-tone siren. Two-tone means two different frequencies. Okay. Here I'm asking you, the first frequency should be 250 hertz. The second frequency should be 500 hertz. Okay. So in order to generate 500 hertz, guys, the delay here has to be 1 millisecond. I think I'm gonna explain it, but it should be very trivial, very easy, because you know, guys, the time from here to here, t should equal 1 over f, 1 over the frequency. So 1 over the frequency, this one should be 2 milliseconds, which is 1 millisecond and 1 millisecond. If you want to generate 250 hertz tone, 250, so 1 over 250 should be 4 milliseconds. That means 2 milliseconds and 2 milliseconds. Very trivial. All what you have to do to generate different tools, just to change the delay. That's it, change the delay. But okay, so all what you have to do, as you will see right now, guys, number one, you have to pull, you have to pull the pin high, and then a delay, pull it low, then a delay, and keep repeating. That's it. By changing the delay, so here the delay is 1 millisecond, here the delay is 1 millisecond. Now the delay, I can make it 2 milliseconds. That's it. That okay? I'm gonna teach it next time, but again, you have all the, so you have all the programs here. Okay. So I'm gonna teach this one next time. Any questions? Great.